Alright, in this video we're going to talk about the chain rule, which is the way to take the derivative of a composite function. So let's say that we have a function y and it's a function of u. Y is a function of u, and that u is a function of x. So we can rewrite y as f of g of x. And to take the derivative, which is dy dx, or alternatively y prime, we take the derivative of y with respect to u and multiply that by the derivative of u with respect to x. Another way to think about it is you take the derivative of the outside function with respect to the inside and you multiply that by the derivative of the innermost function. And you can apply the chain rule multiple times within a function. So let's do one example. And it doesn't really involve inside outside, it just involves powers. The first function I have, the one function I have here is y equals e to the inverse tangent of x. So let's take the derivative. Before we do that, let's analyze. Let's look at this function a little bit. We have e to some power. We have e to some power. And we also have a function inside that power. So we have two parts of this function, and we're going to have to differentiate them. So the chain rule says we take the derivative of the outside function with respect to the inside and multiply it by the derivative of the inside. So in this case, we're going to have to take the derivative of e to the inverse tangent of x with respect to the inverse tangent of x if we say that u is equal to the inverse tangent of x. Just so you know, you can also write this as arctan. And so we have y equals e to the u, and to take the derivative of this, well, the powerful part about this is that the derivative of e to the u is itself, but we still need to take the derivative of u with respect to x. So we have d dx, the derivative with respect to x, of the inverse tangent of x, and that's just going to be 1 over 1 plus x squared. And so we multiply the two together, so we get dy dx, which is equal to dy du times dy dx. Oh, excuse me. That should have been du dx. And in case you don't see it, if you treat these as just normal fractions, the du's will cancel out, and so you still get dy dx that way. So the derivative of this function right here is going to be dy du, which is e to the inverse tangent of x, times this part right here, which is du dx. So I can also write that as just e to the inverse tangent, oops, forgot my argument, of x, and I multiply that by 1 over 1 plus x squared, which just simply means I can just put this in the denominator, 1 plus x squared. And that's my derivative.